Hello everyone. In this video we are going to cover thread and multi-threading. We will look at what threads are, the different multi-threading models and important threading issues. Let's get started. So in this unit we have three main topics. First, what is thread? A thread is the smallest unit of CPU execution inside a process. Think of your process as a factory and the threads or the workers inside that factory. A single process can have multiple threads all running at the same time, sharing the same memory and resources. Each thread has its own thread ID, program counter, registers, and stack, but they share the core data and open files. Then single versus multi-threaded is comparing single thread process only one task runs at a time, but in a multi-thread process multiple tasks run simultaneously. For example, a web browser can download a file, display a web page, and respond to your clicks all at the same time. That is called multi-threading. The next is the benefit of multi-threading. Why do we use multi-threading? Four main reasons. One is responsiveness. The application keeps running even if one part is busy. Next is the resource sharing. Threads share memory, so no extra overhead. Next is the economy. Creating a thread is much cheaper than creating a new process. Finally, scalability. This means a multi-core system's threads run truly in parallel, boosting performance. This is called scalability. These are the benefits of multi-threading. Then next concept is multi-threading. What is meant by multi-threading? Now let's look at multi-threading models. These models describe the relationship between user threads which are managed by the application and kernel threads which are managed by the operating system. The user threads managed the application and the kernel threads managed by the operating system. The user threads are fast and managed by a thread library in user space. The kernel doesn't even know they exist. Kernel threads are managed directly by the operating system. This is slower to create, but the OS can schedule them on multiple cores. These three models define how these two types are mapped together. The first model is many to one model. The many to one, the many users threads map to a single kernel thread. The thread library manages everything in user space. So it's very fast, but here's the problem is if one thread makes a blocking system call, the entire process blocks. Also, since there is only one kernel thread, you cannot run threads in parallel on multi-core. The example is green threads in early Java, GNU portable threads. The next slide is one-to-one model. In this model, every user thread gets its own kernel thread. This allows a true parallelism on multi-core systems. If one thread blocks, the other keep running. The downside, creating too many threads is expensive because each needs a kernel thread. Example for this one is Windows and Linux use this model. Then the next model is many to many. The many to many model is the best of both worlds. Many user threads are multiplexed onto a smaller or equal number of kernel threads. The operating system can schedule multiple kernel threads in parallel. If one user thread blocks, the library can schedule another. This is the most flexible model used in older Solaris and Windows with the thread fiber packages. The next topic is the thread libraries. This gives programmers an API to create and manage threads. The three main ones are POSIX, pthreads used on Linux and Unix systems, Windows threads used on Windows, and Java threads which run on JVM, that is Java Virtual Machine, and use the underlying operating system threads. Pthreads is the most widely used standard. Thank you.